Have you ever stopped to think about what you're really eating when you bite into a sausage? The answer might shock you more than you imagine. Every day, billions of people around the world consume sausages without having the slightest idea of what really makes up this seemingly simple product. But there's a hidden universe behind this manufacturing process that the industry prefers to keep secret. The first major revelation is that not all meat that goes into sausage is what you think it is. When we talk about pork or beef on the label, we're talking about a much broader classification than most people imagine. In modern factories, raw materials arrive in refrigerated trucks at temperatures of -2 degrees Celsius. But here's the first secret. This meat includes not only the muscles you know, but also tissues that rarely reach your plate in other forms. We're talking about heart, liver, skin, subcutaneous fat, and even cartilage. All of this is perfectly legal, and in fact is part of the millennial tradition of complete animal utilization. The problem isn't in using these parts, but rather in the lack of transparency about what really makes up the final product. The selection process happens on industrial conveyor belts, where specialized workers separate different types of tissue with surgical precision. Each category has a specific function in the final texture and flavor of the sausage. Fat, for example, cannot exceed 30% of the total composition, but also cannot fall below 15%. Otherwise, the sausage becomes dry and flavorless. But here comes the part that few consumers know. There's an invisible hierarchy in raw material quality. Premium sausages use specific cuts, while cheaper versions take advantage of leftovers and trimmings from other industrial processes. This differentiation happens right when the raw material arrives. Optical sensors analyze coloration, fat marbling, and even meat texture in a matter of seconds. Darker meats, which indicate older or stressed animals, are automatically directed to lower value-added products. What makes this even more complex is that many factories work with suppliers from different countries. Argentine, Uruguayan, Paraguayan, and Brazilian meat can mix in a single sausage, each with distinct characteristics of flavor, texture, and nutritional composition. There's also an aspect that the industry rarely discloses: the use of mechanically separated meat. This process uses high-pressure machines to extract every last piece of meat from bones, creating a pink paste that becomes the base for many industrialized products. Temperature during this entire process is absolutely critical. Meat must remain between 0 and 4 degrees Celsius during all handling. An increase of just 2 degrees can exponentially accelerate bacterial proliferation, compromising not only quality, but food safety. Modern machines use infrared sensors that monitor raw material temperature in real time. Any deviation triggers automatic alarms and can paralyze the entire production line. We're talking about investments of millions of dollars in technology just to ensure meat maintains its ideal properties. Another little-known factor is the time between slaughter and processing. Very fresh meats processed in less than 24 hours after slaughter can present texture problems. On the other hand, meats stored for more than 72 hours begin to lose essential properties for manufacturing. The industry has developed controlled maturation techniques where meat is kept in chambers with modified atmosphere. Gases like nitrogen and carbon dioxide replace oxygen, slowing oxidation and maintaining the characteristic red color. But perhaps the most surprising aspect is standardization. Large industries process tons of meat per hour, and each batch needs to have exactly the same characteristics as the previous one. This means specialized technicians constantly adjust proportions of different types of meat to maintain a rigorously uniform standard. Internal laboratories analyze samples every 15 minutes, checking not only composition, but also pH, humidity, proteins, and fats. A minimal deviation can mean discarding hundreds of kilos of product. What few know is that there's a parallel market for these selection leftovers. Meats that don't meet standards for premium sausages are sold to manufacturers of lower quality products, creating a chain where practically nothing is wasted. This reality reveals that behind the apparent simplicity of a sausage, there's a complex industrial universe where science, technology, and tradition meet to create a product that feeds billions of people daily. Now we reach the heart of manufacturing, where the magic really happens. What you're about to discover will completely change how you view that smooth and uniform texture of sausage. Everything begins with gigantic machines called cutters, which look like they came out of a science fiction movie. These machines have blades that spin at speeds of up to 3,000 rotations per minute, grinding meat into microscopic particles in a matter of seconds. But here's the first secret. It's not just about cutting meat. The real process is creating a perfect emulsion, where fat, water, and proteins merge in a way that defies basic laws of physics. Normally, water and fat repel each other, but in sausage manufacturing, they need to unite permanently. Temperature during this process is absolutely critical. The mass cannot exceed 12 degrees Celsius during emulsification. Why? Because above this temperature, proteins begin to coagulate prematurely, destroying the ability to form the emulsion. The result would be a grainy, dry sausage with unpleasant texture. To maintain this low temperature, factories use flaked ice added directly to the cutter. It's not ordinary ice, it's special ice, produced with treated water and free from any contamination. Some factories use up to 40% ice relative to meat weight. The cutter blades don't just cut, they create a shearing effect that breaks muscle fibers at a molecular level. This process releases specific proteins, mainly myosin, which acts as a natural emulsifier, allowing water and fat to mix stably. But there's perfect timing for all of this. The emulsification process cannot last more than 8 minutes. Less than that, and the emulsion remains incomplete. More than that, and blade friction heats the mass beyond the safe limit. Specialized technicians monitor every second through temperature sensors inserted directly into the mass. Here enters a technology few know about, the addition of phosphates. These chemical compounds have the function of extracting even more proteins from meat, increasing water retention capacity. This is why industrial sausages can maintain so much moisture even after cooking. The process becomes even more complex when we talk about different types of meat in the same recipe. Pork has different emulsification characteristics than beef. Pork is easier to emulsify due to higher intramuscular fat content, while beef requires specific techniques to break its more resistant fibers. During emulsification, seasonings are also added, but not in any way. Salt, for example, needs to be added at the beginning of the process because it helps extract proteins from meat. Spices like pepper and garlic are added at the end to avoid being excessively ground and losing their essential oils. Modern machines have vacuum systems that remove air during the process. Why is this important? Because oxygen can cause fat oxidation, altering sausage flavor and color. Additionally, air bubbles in the mass can create weak points that make sausages burst during cooking. There's also a secret about ingredient addition sequence. First comes lean meat, which is emulsified until forming a smooth paste. Then, fat is added in small portions to ensure gradual incorporation. Finally, additives and ice water enter. Ultrasonic sensors monitor mass density in real time. A perfect emulsion has a specific density, and any deviation indicates process problems. Computers automatically control blade speed and temperature, making microscopic adjustments every second. What makes all this even more impressive is that different recipes require different emulsification speeds. Frankfurt-type sausages require a finer emulsion, while pepperoni sausages maintain a slightly coarser texture. This means operators need to adjust not only ingredients, but also technical parameters for each product. A little-known aspect is that water quality used directly affects emulsion. Very hard water with excess minerals can interfere with protein's ability to bind adequately. Therefore, many factories have specific water treatment systems for production. Throughout the process, samples are automatically collected for microscopic analysis. Technicians verify if fat particles are uniformly distributed and if there are no signs of emulsion separation. An unstable emulsion can break during cooking, resulting in fat loss and inadequate texture. Pressure is also a critical factor. Machines operate under controlled pressure to ensure mass is homogenized without incorporating excessive air. Too little pressure results in inadequate mixing, while excessive pressure can break the emulsion. At the end of this process, what comes out of the cutter is a smooth, shiny, and perfectly homogeneous mass. This mass has a specific consistency that allows it to be pumped through pipes to the next production stage. It's at this moment that raw meat truly transforms into the product we know as sausage. This entire process happens in a matter of minutes, but represents decades of technological development and scientific knowledge applied to the food industry. You probably never paid attention to what wraps your sausage, but this seemingly insignificant skin hides secrets that can directly impact your health and the quality of what you're consuming. There are two completely different worlds when we talk about casings: natural and artificial. And the difference between them goes far beyond what you might imagine. Natural casing is made from the small intestine of pigs, sheep, or cattle. Yes, you're eating intestine, and that's not necessarily a problem. In fact, it's a millennial tradition that goes back to the first civilizations that discovered the art of preserving meat. But here's what few know. These intestines go through a preparation process that can last up to 48 hours. First, they are meticulously cleaned, scraped to remove any fat or mucosa residue, and then go through successive baths in saline solutions of different concentrations. The process is so delicate that a single imperfection in the intestine can compromise an entire production line. Specialized technicians inspect every meter of casing with magnifying glasses, looking for microscopic holes, scars, or irregularities that might cause leaks during filling. The origin of these intestines also makes all the difference. Intestines from young animals are more flexible and resistant, while those from older animals can be more brittle. Specialized suppliers classify casings by age, size, and geographical origin, creating a global market where quality varies drastically. But there's an aspect the industry rarely discloses. Many natural intestines are treated with chemical preservatives to increase their durability. Sulfites, for example, are commonly used to prevent deterioration during transport and storage. These compounds can cause allergic reactions in sensitive people. Now, on the other side, we have artificial casings, which represent a technological revolution in the food industry. Made mainly from processed bovine or pork collagen, cellulose, or even synthetic materials like plastic. Artificial collagen is created through a fascinating process. Animal skins and bones are boiled at temperatures up to 100 degrees Celsius for hours, extracting natural collagen. This collagen is then purified, concentrated, and molded into uniform tubes through high-precision machines. The advantage of artificial casings is absolute standardization. Every meter has exactly the same diameter, same thickness, and same resistance. This allows filling machines to operate at much higher speeds, producing thousands of sausages per hour without risk of rupture. But here's an important revelation: not all artificial casings are edible. Some are made from chemically treated cellulose or plastic materials that must be removed before consumption. The problem is that many consumers don't know how to identify the difference. Non-edible cellulose casings are frequently used in larger caliber sausages like mortadella and hams. They are more resistant and allow the product to maintain its shape during longer and more intense cooking processes. The technology behind synthetic casings is surprising. Some are vapor permeable, allowing moisture to escape during cooking, while others are completely impermeable, keeping all juices and flavors inside. This choice directly affects the final texture of the sausage. An industry secret is that casing color can be artificially modified. Specific colorants are added to give that characteristic pinkish tone we associate with fresh sausages. Without these colorants, many sausages would have an unappealing grayish appearance. The casing application process also hides technical complexities. Specialized machines inflate casings with compressed air before filling, checking their integrity. Any micro hole is detected by pressure sensors, and the defective casing is automatically discarded. During filling, pressure must be controlled with millimetric precision. Insufficient pressure results in soft and poorly formed sausages. Excessive pressure can rupture the casing or create tension points that break during cooking. There's also a significant difference in how each type of casing reacts to cooking. Natural casings shrink along with meat, keeping the sausage firm. Artificial casings can have different behaviors, some shrinking more, others less, affecting final texture. A little-known aspect is that some artificial casings contain plasticizers to increase their flexibility. These chemical compounds can migrate to meat during cooking, especially at high temperatures. Recent studies raise questions about long-term effects of this exposure. The choice between natural and artificial also impacts flavor. Natural casings are porous, allowing seasonings and smoking to penetrate more deeply into meat. Artificial casings can create a barrier that limits this flavor penetration. Large industries frequently mix different types of casings on the same production line, depending on the desired final product. Premium sausages generally use natural casings, while mass products may use artificial ones to reduce costs. What makes all this even more complex is that regulation on casing labeling varies between countries. In some places, it's mandatory to specify the type of casing used, while in others, this information can be omitted, leaving consumers in the dark about what they're really consuming. Prepare to discover what really keeps your sausage fresh for weeks or even months in the refrigerator. What you're about to know might shock you more than you imagine. That vibrant pink color you associate with fresh sausage, it's not natural. In fact, without chemical additives, processed meat would have an unappealing grayish color. The color you see is the result of a compound called sodium nitrite, one of the most controversial preservatives in the food industry. Sodium nitrite not only maintains attractive color, but also prevents the growth of Clostridium botulinum bacteria, responsible for botulism, a potentially fatal food poisoning. Without this preservative, sausages would have a shelf life of only a few days, even refrigerated. But here's what the industry doesn't want you to know. When sodium nitrite is heated to high temperatures, especially during frying or grilling, it can form compounds called nitrosamines, classified as potentially carcinogenic by World Health Organizations. The amount of nitrite used is rigorously controlled. Legislation allows a maximum of 150 parts per million in the mixture. It may seem little, but considering that a person consumes an average of 15 kilos of processed meats per year, accumulated exposure becomes significant. Another practically invisible additive is phosphates. These compounds have a specific function, increasing meat's capacity to retain water. This is why industrial sausages maintain their juiciness even after long storage periods. Without phosphates, water would separate from meat, creating that unpleasant pink liquid in packages. There are different types of phosphates used: sodium triphosphate, sodium pyrophosphate, and sodium hexametaphosphate. Each has specific properties, but all share a worrying side effect. Excessive consumption can interfere with calcium absorption by the body, potentially affecting bone health. A well-guarded industry secret is the use of isolated proteins. Soy protein, pea protein, or wheat protein are added to increase the apparent protein content of the product. These proteins cost much less than meat, but allow manufacturers to declare high protein value on the label. The problem is that these plant proteins don't have the same amino acid profile as animal meat. You might be paying for inferior quality protein without knowing. Additionally, people with soy or gluten allergies can have reactions even consuming a product apparently made only from meat. Another controversial additive is monosodium glutamate, known as MSG. Although considered safe by health authorities, some people report symptoms like headaches, nausea, and palpitations after consumption. MSG intensifies umami flavor, making sausage taste more meaty and satisfying. The industry also uses antioxidants like BHT and BHA to prevent fat rancidity. These synthetic compounds are effective, but animal studies suggest possible adverse effects with prolonged consumption. The European Union has already restricted the use of some of these antioxidants, but they are still widely used in other countries. A particularly concerning aspect is the use of carrageenan, a thickener extracted from marine algae. Although technically natural, industrially processed carrageenan can cause intestinal inflammation in some people. Recent studies associate its regular consumption with chronic digestive problems. Sugars are also added, not just for sweetening, but to feed specific bacteria during controlled fermentation processes. Dextrose, sucrose, and even corn syrup are common. The problem is that these sugars contribute to the product's glycemic index, something few consumers consider when eating a sausage. Artificial colorants like Allura Red and Sunset Yellow are used to standardize color between different batches. These colorants are petroleum-derived, and although approved for consumption, some studies suggest possible connections with hyperactivity in children. Modern technology allows preservatives to be micro-encapsulated, releasing their action gradually over time. This means a sausage can continue being preserved even after weeks of storage, maintaining fresh appearance and flavor far beyond what would be natural. Some manufacturers use modified atmosphere in packaging, replacing oxygen with inert gases like nitrogen and carbon dioxide. This technique significantly extends shelf life, but can mask natural deterioration signs that would alert consumers about product problems. There's also the use of transglutaminase enzymes, known as meat glue. This enzyme allows joining small pieces of meat, creating the illusion of a product made with whole cuts. It's completely legal, but rarely mentioned on labeling. Stabilizers like xanthan gum and guar gum are added to maintain uniform texture during storage. Although considered safe, they can cause digestive discomfort in people with sensitive intestines, especially when consumed in large quantities. What makes all this more complex is that many of these additives interact with each other, creating combined effects that are poorly studied. The safety of each individual additive may be established, but the effects of combining multiple chemical compounds in the same product remain largely unknown. Specialized laboratories constantly test new formulations, seeking to reduce costs while maintaining the appearance, flavor, and durability consumers expect. It's a technological race where food chemistry advances faster than our understanding of its long-term effects.